Welcome back, students. This is the session 30 from the playlist of NEET Physics Part 1. The chapter is Work, Power and Energy. And the question which I have written here on this board was asked in the CBSE All India Pre-Medical Test a long time back. The question here is, an engine pumps the water through a hose pipe. Water passes through the hose pipe and leaves with a velocity of 2 meters per second. So here, for saving the time, I have already drawn one figure here. Here the water is flowing in the direction of this arrow. The velocity of this water is 2 meters per second, and the length of this hose pipe is assumed to be L by me. The area of the cross section of this hose pipe is assumed to be A. The mass per unit length of the water in the pipe is 100 kg per meter. That is, first thing is, the velocity of the water is 2 meters per second, which has been given in this question. The mass per unit length of the water in the pipe is equal to 100 kg. So M upon L is 100 kg. L is the length of the hose pipe, and M is the mass of the water. So M upon L is equal to 100 kg. So these are the two parameters which we have been given in this question. And the question is, power of the engine is. So there are four options here. First one is 800 watt, second one is 400 watt, third is 200 watt, and the last one is 100 watt. And we have to find the correct option. So we all know that the power is equal to work done divided by time. So this is a general formula which we all know about it. So this power can be also written as work done is equal to force into displacement. Force into displacement divided by time. Now, displacement upon time is the velocity. So power is also equal to force. If I am denoting force by F, that is capital F, and displacement upon time will be equal to V, that is the velocity. So small v is the velocity and capital F is the force. So the power is equal to F into small v, and this is the first equation which I have got. Now, here V is known to us, we have to calculate F. So there is another formula, a general formula, that is force is equal to mass into acceleration. Mass into acceleration. Power is equal to F into V, and I am writing it here. So, mass into acceleration divided by time. Sorry, mass into acceleration only. And so this formula can be rewritten as mass into velocity upon time. So this formula can finally be written as m, where m is the mass, v is the velocity. This is v is the velocity which we have already denoted by small v, divided by time t. So this is equal to F is equal to m into v upon t. So this is the second formula which we have got, and now from these two equations, that is, let's say this is equation number 1 and equation number 2. So from the equation from these two equations, I will get power is equal to, I will be substituting the value of F from this equation number 2 in equation number 1. So I will be getting power is equal to M into V upon T, and this will be square because this is mv upon T. So I will be substituting the value of F in this equation. So this will be equal to mv square upon T. So the power is equal to mv square upon T. Now we know that mass is also equal to density into volume. Let us consider the density of this water as rho. I'm just taking it as rho. Volume is equal to area of cross section into the length of the hose pipe. I have taken the length of the hose pipe as L, and I have also assumed the area of the cross section of this hose pipe as A, as capital A. So this is equal to rho A L. So the mass is equal to rho A L. So what I can do is, let us say this is equation number 3 and this is mass, which is, let us say, equation number 4. So I will be now substituting the value of mass from equation number 4 in equation number 3, and I will be getting power as equal to rho A L V square upon T. Let us say this is the equation number 5. Now if L is the length of this hose pipe and T is the time taken by this water to pass through this hose pipe, then L upon T will be equal to velocity. Okay? So what I will be doing is, I will be substituting this value of L upon T, which is equal to V, in this equation number 5. So what I will be getting is rho A L upon T is equal to V. So, and V into V square, which is equal to V cube. So this is the equation number 6. Now, I don't know, I know the value of V, but I do not know, I still have to find the value of rho into A. Now, as we know that mass is equal to density into volume, we have used this equation or this formula in order to find this equation number 4. So M is equal to rho A L. From this equation, M is equal to rho A L. Okay, so M upon L will be equal to rho A. What I have done is, I have divided this equation on both sides by L. So what I am getting is M upon L is equal to rho into A. And now M upon L has been given here. That is, the mass per unit length of the water in the pipe is equal to 100 kg. So this is equal to 100 kg. So that is rho A is equal to 100 kg. Mass is equal to density into volume. So mass is equal to rho into A into L. And what I have done is, that is, I have divided this equation. That is, this equation is the same equation as the equation number 4. So mass is equal to rho into A into L, and I have divided this equation on both sides by L. So M upon L is equal to rho into A, and this is equal to 100 kg, because M upon L is equal to 100 kg, which has been given in this question. So power of the engine will be equal to rho A is equal to 100, and this V is equal to 2 cube. So this is equal to 100 into 8, and the power of the engine will be equal to 800 watts. So the correct option here is A, that is 800 watt. So in this question, the most important thing was that we first thing is that we have used the general formulas for power, force, and the mass. But here the most important thing is that we have to utilize those general formulas in such a way that the parameters which has been given in this question can be utilized. So we were given only these two parameters. So we have to formulate this equation of power in such a way that we can use these two parameters to get the answer. So in the next session, that is in the session number 31, I will be I will be taking up another question from the same chapter, that is work, power and energy. So till then, have a nice day. Bye.